Hi everyone, this is our first video lecture on linear equations in two variables. Now we all have learned what are linear polynomials. We all know what are linear polynomials in one variable. We all know what are linear polynomials in two variables, and we know what are linear equations in one variable. Now if you know all these four things, then you know what are linear equations in two variables. You already know that. Let's try to understand this concept of linear equations in two variables by taking a few examples. Here you have four equations. On the left hand side, these are linear equations in one variable, and on the other hand, on the right hand side, we have four equations that are linear equations in two variables. Let's take this first one. 4x is equal to 8. It's a linear equation because its degree is 1, and it's a linear equation in one variable because here we have only one variable, that is x. On the other hand, it is 4x plus y is equal to 8. It is a linear equation in two variables because here we have two variables, x and y. Square root of 2s minus 4 is equal to 0 is a linear equation in one variable because here we have only one variable, that is s. Square root of 2s plus t minus 4 is equal to 0 is a linear equation in two variables because we have two variables, s and t. Same thing with 3t minus 2 is equal to 0. One variable, that is t. 3t plus 4u is equal to 0. Linear equation in two variables, and the two variables are t and u. Here we have one variable, that is x, and here we have two variables that are x and y. Okay. Now, these four are linear equations in one variable and these four are linear equations in two variables. So, in general, we represent a linear equation in one variable by this, and we have learned this earlier. On the other hand, a linear equation in two variables is represented by ax plus by plus c is equal to 0. Now ax plus b is equal to 0 is the representation, in general representation, of a linear equation in one variable where a and b are real numbers. By real numbers, we mean that they can be a rational number, they can be irrational numbers, right? And here we have a, b and c are real numbers. Again, they can be rational numbers and they can be irrational numbers. And in this case, a cannot be equal to 0. And in this case, a cannot be equal to 0 and b also cannot be equal to 0. Let's discuss it one by one. Now we know that in this ax plus b is equal to 0, ax plus b is equal to 0. This a is our leading coefficient. We know this. Leading coefficient. And b is our constant term. Constant term. Right? We have learned these things. Now, suppose here we have written a is not equal to 0. What will happen if a becomes 0? If a becomes 0, then this is actually 0 multiplied by x plus b is equal to 0. That is, it becomes b is equal to 0. Right? Now, this is our final equation when a becomes 0. If a becomes 0, we get an equation that is b, the equation is b is equal to 0. Now, this b is equal to 0 is a constant polynomial and not a linear polynomial. It's a constant polynomial. Right? So if it is a constant polynomial now and not a linear polynomial, that's why we say that a cannot be equal to 0. Your b can be 0. No problem in that. Right? Like here, this is 4x is equal to 8. So we can write this, if our equation becomes 4x is equal to 0. Here you have a, but you don't have b. That's completely fine. It's also an equation, but here you don't have b. But this leading coefficient, that is a, cannot be equal to 0. Otherwise, it will be a constant polynomial. Okay. In the same way, here a cannot be equal to 0 and b cannot be equal to 0. Let's understand this. So this is ax plus by plus c is equal to 0. A is our leading coefficient and c is our constant term. Okay. Now let's say that a becomes 0. If your a becomes 0, now your equation is actually 0 multiplied by x plus by plus c is equal to 0. So your final equation becomes by plus c is equal to 0. Now it's a linear equation. It's still a linear equation, but it's a linear equation in one variable. It's not a linear equation in two variables anymore, right? So when a becomes 0, it becomes a linear equation in one variable. What about b becoming 0? So if b becomes 0, your equation becomes ax plus 0 multiplied by y plus c is equal to 0. That is ax plus c is equal to 0. Again, it's a linear equation in one variable and the variable is x. It's not a linear equation in two variables anymore. That's why we say that a cannot be equal to 0 and b cannot be equal to 0. C can be 0. No, there's no problem in that. Like this is the equation 4x plus y is equal to 8. And if 4x plus y is equal to 8, then we can write this as 4x plus y minus 8 equal to 0. A is 4, b is 1 here, right? 1 multiplied by y, so this is b. What's c? C is minus 8, right? But suppose our equation is 4x plus y is equal to 0 and not 8. If this is 0, so in that case, this is what? Basically 4x plus y is equal to 0. So our c is equal to 0. So c can be 0, just like here b can be 0. So a and b cannot be equal to 0, and here a cannot be equal to 0. So this is very important. Now another important point, that the representation of a linear equation in two variables is not unique. It's not unique. Let's take this example. Here we had 4x plus y is equal to 8, right? Initially it was 4x plus y is equal to 8. So let's copy this, Control C and Control V. Okay, so this is 4x plus y is equal to 8. Let's take this. Now here we can write it as 4x plus y, so 1y minus 8 is equal to 0. Another way we can write this equation in another way, and that is, this is 8, so write it as 8 minus 4x minus y is equal to 0. Any problem in this? We have taken this left hand side and we have transposed it on the right hand side. So this becomes 8 minus 4x minus y, or we can say that it's actually equal to minus 4x minus y plus 8 is equal to 0. Same thing, just we have interchanged the positions of minus 4x and minus y, right? So this is our equation. Now same equation, but it has been written in two different ways. One way is this one and one way is this one. In this case, your a is 4, b is 1 and c is minus 8. But what about this case? In this case, minus 4 is a, so a is minus 4, b is minus 1 and c is 8. So compare now. C here is 8, but here it's minus 8. B here is minus 1, but here it's 1. A is equal to minus 4, but A is equal to 4. Right? So that's why the representation of a linear equation in two variables is not unique. Let's take one more example. Like here, you have this. So let's copy this. Control C, Control V. Okay. So I can write this as, let's say that it is actually equal to 4. Now I can write this as square root 2 s plus t minus 4 is equal to 0, and I can write it as 0 is equal to 4 minus square root 2s minus t. Okay, now in this case we can rearrange it and write it as minus square root 2s minus t plus 4 is equal to 0. Now in this case, your a is square root 2, your b is 1, and your c is minus 4. But in this case, your a is minus square root 2, your b is minus 1, and your c is 4. So understand? Here a, b and c, and here a, b and c, these two sets of values are not same here. A here is different, A here is different from this one, B is different from this one, and C is different from this one. That's why we say the representation of a linear equation in two variables is not unique.